Today, I'm going to discuss a separation process which is known as filtration. And filtration basically means separation of solids from liquid. So, uh, suppose if we have to separate any liquid having solid fraction present in it, and we used to separate the solid from this liquid by using the filter medium, and this filter medium will act as a barrier and it will not allow the solid particles, or simply you can say the particles having less pore size can move, and particles having the bigger pore size than present in this medium will be holded, can will not pass through this medium. So the liquid will pass through it and the solids will remain near the filter medium, and that solid aggregation is known as filter cake. Now, what is actually the basic theory of filtration? Let us discuss the basic theory. Basic theory of filtration. So actually the basic theory is when the fluid passes through the filter medium, the solid being deposited in the filter medium, the removal of these solids from fluid results in a build up of solids in the filter medium, resulting in increased resistance to flow as in the filtration process continues. As I uh, told you here, once the filtration starts, the liquid pass through this medium and the solids will remain uh, to this side. They cannot pass to this medium, so they will pile up near this medium. So because of this gathering of this piling of this solid materials near the medium, it will resist the liquid to flow from this from one side to another side. So it will increase the resistance. So therefore, higher pressure differences is necessary to maintain the flow rate of filtering. So when the solids will get piled up here, we have to increase the pressure. We have to increase the pressure to maintain the flow constant. So the rate of filtration can be written as rate of filtration can be written as driving force, which is change in pressure, divided by resistance R. So uh, where the driving force is the pressure required to maintain the flow rate of a filtrate through a filter medium, and the resistance depends on several factors. This resistance will depend on various factors, and this will be discussed later on. So mathematically we can write it as Q is equivalent to dV divided by dt is equivalent to A del P divided by R, where Q is volume rate of flow of filtrate, volume rate of flow of filtrate, A is cross-sectional area of filtrate, and T is the time, filtration time, and R is the resistance, and del P is the pressure difference, and V is the volume of filtrate. Okay, let me draw a diagram. Suppose if this is a filter medium through which filtration is carried out. Suppose the length of this, the thickness of this filter medium is L, and let the cross-sectional area is A. The fluid is passed from this direction and it will leave this direction. Okay, so the fluid, when fluid is pushed to pass through this filter medium, the solids present in it which cannot pass through this filter medium will get piled up on the surface. So let's see, the solids will get piled up here, and let the thickness of solid compilation is LC. So assume the filter cake. This is actually filter cake. Now assuming that the filter cake does not become compressed, uh, R can be described by following expression. If we assume this filter cake is cannot be compressed, and this R can be written then as R is equivalent to mu small r LC plus L. See, this is the resistance. R is the capital R is the resistance, and mu is the viscosity of fluid, and R is specific resistance of filter cake. Specific resistance of filter cake. Small r is specific resistance of filter cake. LC is the thickness of the filter cake, and L is the thickness of the filter medium. Now, if the rate of flow of liquid and its solid content are known, and assuming that all solids are retained on the filter, the thickness of the filter cake LC can be expressed as the LC here. It can be represented as LC is equivalent to solid content V, volume of the filtrate, divided by area. Means uh, if the rate of the flow of liquid and its solid content are known, and if we know the solid content and the volume, and if we assume that the solid particles, all the solid particles have been retained on the surface, then we can write this LC must be equivalent to S multiplied by V and divided by A, where S is the solid content. Now we can write R is equivalent to mu R SV divided by A plus L. By simply substituting, I have simply substituted the value of LC in this equation, and I got R is equivalent to mu R, this SV divided by A plus L. Now we can put this equation in, uh, say this is equation A. Put this in, put equation B in A. We will get Q is equal to A del B divided by mu or SV divided by A plus L. So from this equation, this equation may be regarded as the fundamental equation of filtration. This will be regarded as fundamental equation of filtration. Fundamental equation of filtration, and can be used for scale up if converted to appropriate forms. Now let's in general the filtration, now discuss the two types of filtration. In general, filtration process may occur in two phases. Number one phase is constant rate phase, constant rate filtration, and B, second is constant pressure filtration. Let's discuss them in the second video. Uh, Thanks for watching this.